Howdy! Today we're going to do something a little bit different. A GameMaker user asked me if I could update this really old 3D project to GameMaker Studio 2 and reduce the need for compatibility scripts, so I'm going to do that. There is a text-based version of this guide available in the description, which also has a download for the updated version of the project if you want to tinker with it. With that, let's get started. The first thing we're going to want to do is download the original project from the GameMaker RU website. The project was originally made by a user named Vendette in 2010. To download it, we just go to the page linked in the description and click on this download button very conveniently. Save that wherever and extract the zip file. We're going to want to import the project into GameMaker Studio 2 to actually perform the update, but we cannot import GMK files directly into GameMaker Studio 2 because they're too old. So instead what we need to do is download GameMaker Studio 1.4, which you should have access to if you own a GameMaker Studio 2 license. You want to go to yoyogames.com, log into your profile, go to Downloads, and then go to GameMaker Studio 1.4, and then download the IDE. Once you've downloaded and installed GameMaker Studio 1.4, you're going to want to open it. Then you want to go to Import. You'll need to find the Road Test 22 file you downloaded that was in the zip file. Make sure the filter is set to include GMK files, otherwise the file won't appear. Once you've selected the file, click Import. You'll get a warning, but just ignore it. If you run the project at this point, you'll see that it all works, but everything's a little messed up and most of the textures are wrong. So we can fix this here and now, but there's not much point. So for the next step, all we want to do is save this project and close it. Now, in GameMaker Studio 2, we can import the 1.4 project we just created. Go to Import, navigate to the project folder, in my case, Road Test 22, select the project, and open it. Then you'll be prompted to save it, so let's save it. After the project is finished importing, we can try running it again. Look, now it's even more broken. The view is completely wrong and the textures are still messed up. So let's get on with fixing stuff. If we look in the notes, we can see a compatibility report stating all the functions that have been added that we want to remove. The first thing we're going to do, now we've imported the project into GameMaker Studio 2, is open the camera object's events. The first thing we'll do is replace T3D start. This is really easy. We can replace this with GPU set Z test enable and GPU set Z write enable. This essentially allows writing and reading from the Z buffer so that you can actually have depth sorting in 3D environments. The next thing we're going to do is go to step and replace mouse Y with device mouse Y to GUI, so that when we do some view stuff later, we don't have the inability to look up and down anymore. An optional thing we can do here is half the rate of increase of pause and change the game's FPS to 60, if we want 60 FPS. Next, we'll look at the draw event. The first thing we can replace here is D3D set fog. This one's really easy because we can just remove it from the draw event, pop it in create, and replace it with GPU set fog. The arguments are exactly the same, so this is really easy. The final thing we need to do is replace D3D set projection. This requires a few steps because we need to set up a view, assign a camera to it, and give it the proper matrices. So the first thing we're going to do is go back to create and enable views. This is done with view enabled, and then we want to make sure our view is visible. Next, we want to create a camera and bind it to the view. I'm going to call it camera. And then we bind it with view set camera, with the view index 0 and the camera being camera. The last thing we need to do here in create is give the camera a projection matrix. This is done with camera set proj mat. Then we choose the camera, and then we build a matrix with matrix build projection, and in our case we're going to use perspective FOV because regular projection perspective is a little bit glitchy, and we don't want an orthographic view because we want things that are further away to look smaller. For this, I'm going to choose the values -60 for the Y field of view. The aspect ratio will be negative view get W port divided by view get H port. Z near will be 1 and Z far will be 32,000. To explain why FOV and aspect ratio are negative, basically GameMaker Studio 2 does a weird hack to convert 3D space into a pseudo right-handed space, but that's different to how GameMaker used to function, which used to use left-handed space in 3D. So we use the negative values to put it back into the correct space. The aspect ratio is basically the view width by the view height in order to keep everything square. 60 degrees is just a nice value for a field of view, though you'd want this to be customizable in a public game. The Z near and Z far values are basically the GameMaker defaults, but you usually want to keep the range as low as possible in order to minimize Z fighting. Finally, what we want to do is set a lookat matrix for the camera, and we do this in step event, and we use the function camera set view mat. Pass our camera, and then we want to matrix build lookat. Now the arguments for this are very straightforward because we can just take them from D3D set projection. After that, we can actually just delete the draw event from the camera entirely. Blam. And now, if we run the game, we can see that the projection is now correct, even if the textures are messed up, and we can still look around again. Sort of. We'll stop with the camera for now and move on to fixing textures. We're going to fix the textures in the IDE for now, but I'll discuss a way we can fix them using shaders later. All we want to do is open up the sprites and enable separate texture page. Now if we run the game, well that's disappointing, isn't it? Well, everything's using its own texture, but it's not quite right, is it? Well, the reason for that is that the textures aren't actually power of 2 size. So the textures get padded up when the game's compiled, and then the full textures end up rendering with this padded region in, so it looks wrong. To fix this, all we need to do is change the textures to power of 2 sizes. We can actually delete background 1 because it's completely unused. The road is already power of 2 in dimensions, so we don't actually have to change that. The grass, however, is 150 by 150, which is not a power of 2. I'm going to change it to 128 by 128 because that's the closest power of 2. The concrete's not a power of 2 either. I think I'm going to change it to 256 by 128 and not keep the aspect ratio. The textures do not need to be square, their dimensions just need to be powers of 2 individually. I prefer to downscale when resizing textures to powers of 2, but you can do what you want really. Now if we run the game, hey, perfect, everything looks like it should now. Even though we've reduced the resolution of the textures, it looks virtually the same as the original project. Before continuing and replacing the remaining compatibility scripts, I'm going to do a little bit of name cleanup so that they're a little more descriptive. I'm going to rename background 0 to SBR road. I'm going to rename background 2 to SBR grass. I'm going to rename BKG concrete, which does actually have a useful name, to SBR concrete, just for consistency. Then, using global find and replace, I'm going to update them all in the code. I'm going to do the same with the paths. I'm going to rename path 0 to path road XY, and rename path 1 to path road Z, since that's what they control. At this point I can still run the game, but now some useful resources have better names. Now we can get on with the tedious bit, updating Object Road. The update and removal of the compatibility script in Object Road isn't particularly difficult, it's just tedious and time consuming really, and sort of difficult to explain, but I'll try my best. Before we move on to updating Object Road, I'm just going to add a sneaky few functions to the camera, and then we can close it for good. These are enabling texture repeat, texture filtering, and setting the cull mode to counterclockwise. We'll start with the simplest bit and remove the background compatibility scripts. I'm going to move these texture getting functions to the draw event, since that's the only place they're used. Make them locals. And then update the script. So instead of background get texture, we'll just use sprite get texture. with the image index of 0 since all of them are single image sprites. Then I'll give them slightly more useful names. We can also remove the D3D set culling settings here since we now set the culling globally. This will make the grass floor invisible for now, but once we replace D3D draw floor, that'll not be a problem anymore. As you can see. We'll replace D3D draw floor with a vertex buffer. If we go to create, we'll first need to create a vertex format. The vertex format we need has 3 different attributes: position 3D, color, and text coord. This is just so we can use it without needing shaders. We will create the vertex format starting with vertex format begin, then vertex format add position 3D, vertex format add color, and vertex format add text coord. Then we will set it to a variable called vertex format by saying vertex format equals vertex format end. Now we need to create a vertex buffer for the field. I'm going to call it field vbuff equals vertex create buffer. To begin adding vertices to a vertex buffer, we need to use vertex begin and target the vertex buffer and use the correct vertex format. To finish building vertex buffers, we have vertex end. After we end a vertex buffer, it's usually useful to freeze it unless we intend to change it later. This speeds up submissions of the vertex buffer to the graphics pipeline. Now we need to actually populate the vertex buffer. In this case, we'll be using a triangle list type buffer. So we'll need to define 2 triangles for this plane in order to make a square. To begin with, we'll establish some baseline variables based on D3D draw floor in order to make building the buffer easier. We'll make a bunch of locals and give them reasonable names, like this. I have got a lot of stuff copy and pasted ready because this bit is a little bit tedious and it would be a bit boring to watch me type the whole thing. If you want to see the code in more detail, obviously I recommend checking out the written guide. I like to make a local variable that references the actual buffer so that I have slightly less typing to do. This means when I add something like a position 3D, I can just slap in a B instead of the full name. So in this case we want X min, Y min, Z, and then we need a color in order to match the format, which in our case wants to be white, but we've set that in a local variable in case we want to change it again. So we can call it color. And then I've also set alpha to a local variable, so if we want to tweak it, we can tweak it. And then it needs a texture coord. And I need to learn how to type. And we have to do that for every single vertex. So in order to speed things up, I'm just going to paste in the triangle building I did before, because it just takes a lot of time and requires a bit of thinking. Again, look at the online guide if you want to understand this a little better. But essentially, I just use the local variables I've established to build the planes faster. And that is essentially the field vbuffer done. Now, I can remove D3D draw floor and even the draw set color to white and replace it with a vertex submit. Tell it that I want it to submit to the field vbuff. Tell it I want to use a triangle list. And tell it to use the grass texture. Now if I run it, the field should have reappeared, but we're using a vertex buffer now, instead of D3D compatibility scripts. Hey presto. Now the last bit is the most tedious bit, and that is replacing the actual road and its shadow and the concrete pillars with vertex buffers, because there's 2 big loops. This first loop essentially calculates where all the points in the road go, and this second loop then draws primitives based on where all those points are, which is not super efficient because it means it's generating this buffer every single time it draws the road, which is not necessary. So when we use a vertex buffer, we save all that math, put it back in one place, and it'll speed up rendering significantly too. The nice thing is we can actually combine them. The easiest thing to do is to grab this entire loop, put it in the create event, and then merge them. We can remove the count variable, because it actually has the same value in it as I does in the loop. So we replace this with I mod spoke div for generating the concrete pillars, which is done here, and we can just remove the variable. I'm then also going to make a lot of these variables local because they're not, and they're better off being local. Now we get to see where we can merge code. We'll ignore this last section for now because it doesn't need looking at, but basically anywhere that these arrays are read to or written to can sort of be merged into one line to save some time. So we'll establish some variables as local first. And then basically anywhere where these arrays are set, we just set it to the matching read. So if you look, that's set to that, that's set to that. So we can just take that and put it there instead. And then just repeat the process for all of them. It is a little bit tedious, but you should get the idea. In fact, because Z1 and Z2 are just established like that, we can actually just remove that completely. And then these are the most complicated ones, the V coordinates, because they have 2 steps to them. We can simplify these by taking that, putting in brackets, and then moving it where it needs to be. That leaves the array completely eliminated. We do need to make sure these 1s and 2s are moved over here so that it's before x1, y1, x2, and y2 are redefined. Otherwise, we'll end up with some glitches. And then finally, we have to convert all of these D3D primitive functions into vertex buffer functions instead, which again is really tedious. So what I might do again is just copy paste, and you should just check out the text-based guide to see sort of what happens, because essentially I have to replace each of these with a vertex position 3D, a vertex color, and a vertex text coord. And it takes a bit of time. We'll need to create vertex buffers in order to replace the primitives used here. I'm going to use 2 vertex buffers, one for the road and its shadow, and one for the concrete pillars. So let's create some buffers. We'll need a buffer for the road, and we'll need a buffer for the pillars. We'll want to start each of them before the loop, and end each of them after the loop, making sure we use the correct names. For this bit where we do the pillar, when we add a vertex position, etc., we will target the pillar's vbuff with the position, and when we do anything anywhere else, we will do the same thing but with the road vbuff instead. So for all this stuff, we'll be updating the concrete pillar generation to replace D3D draw cylinder. The updated pillar loop now looks like this. We now have some local variables specified to help us change the resolution and the size of the concrete pillars, the color set, and we just basically build it in a loop, building up walls in every direction until full rotation is completed. That adds a cylinder to the buffer. Again, updating the road one is a really tedious one, so I will just paste in a version I made earlier just to speed up the process. It's essentially defining all the same vertices as before, but splitting the function up into individual sections. Once we've updated these functions to the vertex buffers, all we have to do is submit them, which is the same way as before. We just change the variable names. Now when we run it, it looks fine. So now, just to prove that everything is all done and updated, we'll go to Script, right-click Compatibility, and delete that folder, because we don't need it no more. And if we run it, we'll see the demo now functions perfectly without the use of compatibility scripts. I know some of this has been a little bit vague because I don't really want to type tedious vertex buffer building functions all the time, although I did make a little library that makes building vertex buffers a little easier. But if you are missing anything, of course, or if you want to see how the conversion process works a little more in depth, check out the text post because I explain it a little better there. So there is one more thing I wanted to cover, and that was basically a better way of handling multiple textures without putting them all on separate texture pages. This allows you to keep the texture atlas that GameMaker generates without having the same texture on everything. So let's get into that. We'll use a shader to update the UV so they don't render more than they should be rendering from a texture page. So to appreciate this, first we'll disable separate texture page for all the sprites again, and then give it a little run so we can look at it and go, ew. And as you can see, everything is ugly again. Now we can work on fixing stuff. All we need to do is create a shader, and this is not a scary shader, so don't worry. And we'll call it shader UV correct tiling, because we want it to tile for the grass. We can leave the vertex program the same because we're not transforming anything in weird ways. However, in the fragment shader, we will need to correct the UVs. So we will need to pass a uniform of the correct UVs, which will be a uniform vec4 correct UVs. Then to make life easier, we'll create a function which will return a vec2. So we'll go vec2 correct UVs tiled. And that takes in a vec2 original UVs and a vec4 which is UV mapping, which is essentially we'll use the uniform for that. Then all this does is return a vec2, but the values in it need to be calculated. So the way we will pass the uniform is that it will be 4 values, and it will be the left, top, right, and bottom UVs of the actual texture. So what we will do is we will use the mix function to interpolate based on the original UVs to the new UVs. So we'll use UV mapping 0, which will be the left point of the texture, to UV mapping 2, which will be the rightmost point of the texture. And we will use the original UVs, and we'll use the X value of that. But we will not just do that, we will take the fractional component of that in order to enable tiling. We can just duplicate that line, replace that for a Y, and then we update to this to 3, which will be the bottom of the UV texture, and this to 1, which will be the top of the texture, and blammo. And the only thing we need to update now is, instead of using VV text coord there, is we use our function correct UVs tiled, pass in the texture coordinate, and pass in the correct UVs. And that's the shader done. Now, when we draw, we want to set our shader. And then reset it when we're done. We will need the ID of the uniform. Which is done with shader get uniform with the name correct UVs. Then for each texture, we'll need to pass the correct UVs of the texture. So we will get our UVs, and yeah, we'll just establish a local variable named UVs, and then for each buffer, we'll set it to the correct texture coordinates. And then pass those UVs like so. I'm passing the uniforms like this instead of via array, as the texture get UVs returns an array with 8 entries, and the shader will only accept 4. Passing uniforms that are bigger than the actual uniform works on some platforms, but on others it can have really, really bad results. So we kind of want to keep the amount of data we pass the same size. And then now we can just copy and paste that for each texture. Assuming we've done everything correctly, now when I run the code, we'll see all the textures are good again, even though they're all on the same texture page now. And that's the beauty of shaders. And with that being said, I think I've covered everything I wanted to. So, okay, thanks, love you, bye.